Okay, so today is also we're going to do building a trigonometric model. So a trigonometric model would be a graph or an equation and an equation that represent some sort of cyclical motion. What I mean by cyclical is it goes back and forth or up and down, side to side, things like that. Objects that are bouncing, objects that are spinning, have these properties. Any sort of phenomenon involving like the sun or the moon, objects rotating around other objects, and things like that also could be described mathematically with these techniques. So we'll start with a Ferris wheel, a nice simple example. A Ferris wheel of 25 meters radius takes 50 seconds to make a full rotation. Passengers get into the wheel at the bottom, 1 meter off the ground. Build a graph and an equation that represent the vertical height of a passenger. Okay, so what I first want to do is just draw a side representation of this Ferris wheel here. Okay. So what I'm going to be doing is sort of trying to represent the vertical height that a passenger goes up. So you can imagine if a passenger rotates around, they would reach a maximum height and then back down a maximum height, and so they would keep going back up and down, up and down. Now the horizontal location of the passenger can also be represented by a trigonometric function. But we're just going to do the vertical height only. If you wanted to do this horizontal height, it would be a very similar equation. Not the horizontal height, but the horizontal displacement. So what we need to do is we need to start getting a little bit of information here. So the height looks to be like, and then remember that they get in 1 meter off of the ground, and then this is 25 meters and this is 25 meters, and so therefore the maximum here looks like it's going to be 26, and the minimum looks like it's going to be 1. And so I can figure out the amplitude here by doing that simple formula of max minus min, or 26 minus 1 divided by 2. And it looks to be 25 minus 1 is 26 minus 1 is 25 divided by 2 is 12.5. This is the amplitude, or this is the A value here. The period is the length of time that it takes to complete a full cycle. It's stated in the question that the ride takes 50 seconds to make a full rotation, so the period is 50. So since I know that the period is 50, I want to figure out the K value. So K is equal to 2 pi over 50. So I take these two and switch their locations due to cross multiplication, and I get K is equal to 2 pi over 50. Okay. Then I already know the maximum, and I know the amplitude. So I'm going to go ahead and figure out the vertical shift. The vertical shift is oops, sorry. Well, let me write it like this here. The vertical shift. Remember that the vertical shift is maximum is equal to the vertical shift plus the amplitude. I know that the maximum is 26. I'm searching for the vertical shift, and the amplitude is 12.5. Okay. Wait a minute, I messed up here. My maximum is not 26. My maximum is 51. 51. Let me demonstrate that. That was a silly error. 1 plus 25 is 26. And then plus another 25 is 51. Thus making my amplitude 51 minus 1 divided by 2, or 25. And therefore changing this equation as well. 51, 25. I subtract 25, subtract 25. I get the vertical shift is 26. Makes sense. And now the phase shift. The phase shift, if I use the cosine graph, is the length of time between the first maximum and the y-axis, which, remembering that the y-axis represents when the person gets into the Ferris wheel, or it's when time is equal to 0. And so the phase shift is going to be negative 25 seconds. Let me re-explain that. So if someone gets in here, that's at time 0. So imagine us getting into, imagine the graph here. I'm going to have my first maximum at 25 seconds, and then 50 seconds, and 0 seconds, because it takes 50 seconds for the whole thing to rotate. Okay, so I've got 0, 25, and 50. And so remembering that the phase shift can be defined as the distance between the first maximum and the y-axis, if I use the cosine graph. And so, since my first maximum is at 25 seconds, then this is the phase shift. Okay, so now I've got all of the information here. The vertical shift, remember, is variable c. The phase shift is variable d. We already figured out the k and the a. So we've got a d, a c, a k, and an a. And so we can make our graph. I'm going to call this h of t instead of f of x, because I'm dealing with height here and time axis the height and time axes. Alright, and so now what I'm going to do is I'm going to place in my A value, 25, cosine of the K value, which is 2 pi over 50. We can reduce that to pi over 25 if we want. T minus 25, that's my D value, and plus 26. Here is the graph. Just finding my C, my A, my K, and my D. Now that I have the graph, now that I have the equation, I can make the graph. Okay, so I know that from 0 to 50 and 25, and then I'll just go to 75 as well here. Alright, so I get in at the bottom of this Ferris wheel, which is 1. And then I go all the way up to 51. And it takes me one full 50 seconds to go from all the way to the bottom to the top to back down to the bottom. And then we know that right at the top here is halfway through the ride at 50 seconds. Sorry, 25 seconds. So I'll make my graph like this, and then it would go up again, reach a maximum at 75, and so forth. It's not such a great graph, but these curves are not so good. But it's got some of the main points here. I want to label this the height axis, and I want to label this the time axis. Excuse me. So we notice we have most of the key features. Okay, it's pretty clear that the person gets in at the 0 seconds. 0 seconds, by the way, corresponds to when you get into the ride. Then you go up and back down and so forth. It takes a full 50 seconds for you to complete a rotation, and you can see that the maximum height is 51, which erroneously I wrote down previously as 25, but we ended up fixing that. So the original graph of the Ferris wheel helped. Then the math involving the amplitude, the period, and the vertical shift and the phase shift were all found kind of right in here, so that I could find my A, K, C, and D values. And you can build the equation and the graph as well. Okay? Don't forget to label your axes. And that's basically the idea on those.